here we go. Solving absolute value inequalities. To solve an absolute value inequality, we get to isolate the absolute value expression. Then you write a compound inequality, right? And so you can either have an and inequality, and you don't decide what it is till you get to this step. This is where you judge the type of inequality. So since I see a less than sign, it's an and compound inequality. What do you do now? You solve that inequality and graph. So open dots come from no lines underneath the inequality sign. So open dots came from this story can be written as one story. 0 comes first, pointing to 0, x, pointing to x, 4. So these are open dots. And on absolute value inequality, they're either both open or they're both closed, okay? So the open dots came from the fact that these were no lines underneath. No equal signs, that's why it's an open dot. No equal signs make open dots. This is like a part of an equal sign there. Those would make closed dots. And I'll point that out. Another thing, how do you know what direction to shade? Do you shade out or you shade in? Because this was an and story. You shade between. I call it the barbell. That's what I call it. Because it looks like a barbell to me. It's a very small one, but it is a barbell. The or story makes airplane wings. To me. Again, I just have to make stories up to remember things. And I never forget them. Because I made them up myself, just like you could, if you want to. Make up your own stories. Just as long as they give you the truth. Now, don't say, oh, I washed my car so it rained. That's not the truth. That's a coincidence. But the fact that these are no lines underneath make open dots, that's the truth. The fact these are an and story, that's the truth. Okay? That'll happen every time. If there's one to be found. Or sometimes there's just not a story. Okay, let's do that. Eeny, meeny, miny, mo. This was an open dot one. Let's do number 2 where there's a closed dot. So this is where the sticky note comes in because there's not enough room to solve this inequality. I'm even going to cover my number line so you can see what I'm doing. I'm going to follow the steps. Isolate the bars. So that means I take it. This is similar to yesterday, bringing in prior knowledge. Subtract 5, subtract 5. Bars are isolated. Oh, pickles.
less than or equal to 4.
Now, I have to judge.
It's an and. See that less than sign? Lazy L.
Less than means I have an and compound inequality. Now, this is what's a little bit different. When you broke it into two cases on equations, you just put one with the negative of the 4 and one with the 4. But in inequality, you should have started switching signs of values. You have to switch the inequality along with the sign. Did you remember the rule? If I multiply or divide both sides by a negative number, I have to switch the signs. Remember that rule with inequalities back in Algebra 1 or even pre-algebra? Yeah, okay, that's what we're going to do now. Because I'm going to make this guy negative, this guy gets switched. I call it the switch step. Okay. What they said, they didn't even use words up here. They just said solve the compound inequality. So you've got, after you decide it's an and, you've got a case of x minus 1, switch the sign. I call this the switch case. Again, silly. But it helps me remember what to do. I got to switch two things, the inequality and the sign. Between the two stories is the and. That's my silly little abbreviation for and. Now I say stay the same. So I write it without bars, x minus 1 less than or equal to 4. Okay? Now if it starts with an equal to up here, it stays with an equal to down here. You'll never start with an open dot and end with a closed dot. You'll always start with an open dot, end with an open dot. Start with closed dot, end with closed dot. That's good. And they're both going to be the same. Because they'll mess with your head on your choices on the homework and the test. So be ready for anything. Okay, now we get to solve. That means I add 1. So it's x is greater than or equal to negative 3. And add 1. X is less than the pickles. I said it and didn't write it. Can you see my right? Yep, you can see it. X is less than or equal to 5. So I can put these two together. I'm going to get another sticky note. As one inequality. I can only do this for the and. I can't rewrite for the or. Negative 3 is pointed to closed dot x, closed dot 5. I'm going to graph it. Negative 3, I'm lazy. 5, closed dots. And is a barbell. In between. Where did the barbell come from? Because if I just do this greater than or equal to negative 3, it points that way. If I do less than 5, it points this way. And so it's everything they have in common. See? That's where the barbell comes from. It's like an intersection of the two directions. That's why it's a barbell. That's the and story. Isolate the bars, judge the type of inequality, play the game. In both cases, you'll do switch and stay the same. Solve them. And can be rewritten or cannot. I'll show you that example in a heartbeat. soon as you're done with this. Discussion, talking, fun, happy, algebra. We like that. Oh, I do, yeah. And you can do it. Let's put it that way. You wouldn't be here if you couldn't get this level of thinking inside. So that is your example number 2 for this is compound inequality of an intersection. Okay, let's do Fuzzy. Use a similar method to solve absolute value inequalities that have a great or. That's my silly saying symbol. The other one was less than. This one's great or. And it's just silly. Okay, do that. So here's our example. I isolate the absolute value expression before I do anything. So I have my bars alone. Then I judge. And this symbol gives you an or story. That's where I got the or. Not up here, because that could change. If I multiply or divide by a negative number, that could switch. But this one at the bottom, after the bars are isolated, you judge, it's a great or. So once it's an or, these are open dots. But you can't write it together. That's your answer. Open dots. And then both directions, this is airplane wings. Ors make airplane wings. Again, that's silly Fisher talk. But it sure helps me see what I just did. The or story that I got from my algebra will make me draw outward. And if you use your number sense, I want the numbers that are less than 2, which go to the left, or greater than 8, which goes to the right. Or is a union, not an intersection. So or is, everybody can come to the party if you're less than 2 or greater than 8. Up there, you can only come if you were you were between, well, what were the numbers? -3 and 5. So that's the dealio. So let's do one of those. Why don't we go ahead and do a closed dot one for number 3. Oh, unless you want to do a number 4 where you divide first. Somebody have a preference? 3 or 4? 3 or 4? Somebody make the call. 4? Okay, let's do number 4. Thank you. I want to meet your needs. I know it's hard. But, yeah. What looks like what would cause me a fit might not cause you a fit. So think of it as feedback. Okay, right here, right now. First things first, isolate the absolute value expression. So I'm going to rewrite my story. Greater than 6. I have to move the 2 that's being multiplied by division. Now I have to judge. This isn't great or. So when I break it out, I put x
plus 2 switch, switch, or x plus 2 stay the same.
Getting the switch, do that first. And then just stay the same second again. It's so when you have your numbers in order, yeah.
Now we get to solve. Subtracting 2 from both sides because it's being added. No signs changed. Subtracting something doesn't make the sign switch. It's that multiplying. Subtract 2, x greater than 1. This is the OR.
Once you judge an OR, it stays an OR, and that means I have
open dots on -5 and on 1, and it goes out like an airplane wing. That is
number 4. And you see the puzzle? Just like a little puzzle, like a little recipe. We just cooked ourselves a compound inequality. How does it taste, right? Okay. Set. This is probably just brand new to you.
So let it sink in, study the ideas. That's why I want to do just a little bit more practice over here. Okay, let's see.
We do number 4.
I'm going to need a sticky note because there's just not enough space for me. I'm a fat writer. X plus 3 minus 1.5 less than negative 2.5. And I'm going to add 1.5 bar x plus 3 bar less than negative 1. That's interesting. Interesting.
Can an absolute value be less than a negative number? Can an absolute value be a number less than a negative 1?
No. So no solution. Stop. Because this is less than, no solutions. Less than a negative, no solution. That is not what they have in the answer key. I'm glad I picked that one because the answer key is wrong. It happens. But there's just no argument.
You know the definition of an absolute value? Right? It's got to be positive. Can be 0, but it's got to be 0 or more.
Okay, that was great. That was good. Okay, let's do number 7. Now, if it was an or, that's a different story. But an and, not going to happen. Okay, number 7. How to get rid of a half from a side of an equation in algebra.
Any fraction masters? You never really divide by a fraction. You always multiply by the reciprocal.
So reciprocal of half is a 2. Now you are fraction masters. These guys cancel. Okay, now I have to judge. That's a positive, and that's a gray to or. Then I break it out. X plus 5, switch, X plus 5, stay the same. My or got in. My or crowded out my -4. Bad. Any question about the or?
Great or.
Okay, subtract 5, x is less than or equal to a -9, or subtract 5, x is greater than or equal to a -1. So you pick the graph with the closed dots. I'm very sloppy. And airplane wings for or. Airplane wings for or. Airplane wings for or. That is nuts.
Maybe I'm looking at the wrong reteach or the wrong practice. That's crazy. Yep, they goofed on number 4. Just straight up wrong.
All right, let's answer these beautiful word problems, then we'll be done.
These are the rendition of those, remember the tolerance of the furnace before it kicked on again, or the air conditioner? This is the same story, but they're giving you some inequality words in the story. The organizers of a drama club wanted to sell 350 tickets to their show. The actual sales were no more
than
35 tickets from this goal. Write and solve an absolute value inequality to find the range of the number of tickets that could have been sold. Now, you guys know the range. You add 35 and subtract 35 from the 350. But the inequality itself comes from the word no more than. So if there is not a symbol that says no more than in the inequality, it has to be a different set of words. If I am no more than, $50 away from whatever, that means I have $50 or less.
So no more than is another word for less than or equal to. So it can't be any more than 35, and it is, remember from the furnace story,
the range is at 350. So it's either bigger than 350 by 35 or it's smaller than 350 by 35. And you don't even have to do the algebra.
You can just, the smaller number would be 350 minus 35. And the larger number is 350 plus 35.
But it's nice for you to experience the word no more than means less than or equal to. There's enough stories. See where these algebra comes from. There's like, you name it, I got a math story for you. Okay. The temperature at noon in Los Angeles on a summer day was 88 degrees Fahrenheit. How wonderful. During the day, the temperature varied from this as much as 7.5 degrees Fahrenheit. Write and solve an absolute value inequality to find the range of the possible temperatures for that day. So another word for as much as is like no more than. That's like the max variation. So it's still a less than or equal to story. So you have your 88 degrees and you want to add it to a positive 7.5 and a negative 7.5. So if you add 88 to 7.5, that's the big number, 95.5. And the smaller number is subtracting 80.5, something like that. There you go. There's a range of possible temperatures for that day. And that's a great example of absolute value inequalities. Range, range. Looking good. Okay. Anybody want to do any others? See any other examples, or would you rather just do your homework? Okay, let's do that. Thank you for listening. I'm going to turn this off.